Hello guys, this is Dread and I will be taking you homogeneous function. Please listen up as this concept is very important in handling some difficult problems that we have ahead. Alright, so let's go on. No, sorry for the clarity. So a function is said to be homogeneous. The function f x y is said to be homogeneous if it can be expressed in the form x raised to power n then phi y over x. So this is when a function is said to be homogeneous, when it can be expressed in the form x raised to power n then phi y over x. Okay, let's take an instance. Given a function of the form fxy as root x plus root y over s squared plus y squared. Okay, let's see if this function is seen to be homogeneous. Now, our aim is to express this function to be in this format. Okay, the first thing we need to do is to factorize x out. So from the numerator now, let's bring root x out. So if root x is brought out, what will be left here is 1, then plus root y over root x. As we all know that by the time we open the bracket and by distributing this root x to everyone inside the bracket, it will straighten up to give us what we have here. Root x times 1 is root x, and root x times this fraction, it will simply cancel the denominator and giving us root y back. Alright, let's do the same thing for the denominator by bringing out s squared out. Okay, here we have 1 plus y squared over s squared. Alright, so we can further simplify. We have root x into brackets 1 plus y over x, everything under the root sign since both of them are affected by the roots. Then we have s squared to bracket 1 plus y over x all squared, close brackets. And we can simply see that we can use law of indices here to simplify this. So bearing in mind that the power of x here is half, because it's a root sign, square root sign, so the power will be half. Then we have x raised to power half, then minus the power of x here, which is 2. Then with this 1 plus root y over x, then over 1 plus y over x all squared. Alright, so together now we have x raised to power half minus 1 is minus 3 over 2. Then the expression we have here is somewhat similar to this, because this expression is fully in terms of the ratio y over x. Hence, I'm going to be putting phi y over x. Now that I have fully expressed this in this form, so I have known that the function is homogeneous. Alright, I hope you are following. Okay, in addition to our previous points, we take note that there is a certain power assigned to x from the calculation. So this power is what we know as order of homogeneity. Order of homogeneity. Alright, so the power assigned to the x while trying to reform the function of f of x and y in this format is the order of homogeneity. So take note of that. Alright, so let's do one more. Let's see if this function is homogeneous or not. Alright, so we have a naught x raised to power n plus a1 x raised to power n minus 1 y plus a2 x raised to power n minus 2 y squared, continuation till we get to en minus 1 x raised to power y minus 1 plus en y raised to power n. So given a function which is so long like a snake and we want to prove of its homogeneity, so we are still going to stick to that same rule irrespective of how any function might look like. Okay, so let's try to factorize. We all know that the highest degree of x in this place is n, because every other degree of x is decreasing by 1 as we move rightwards. All right. Having known that the highest degree of x is n, so it's very, very easier for us to factorize x raised power n out. Okay, so x raised power n out of the series, then what will be left here? We have a naught plus what will be left here when removing x raised power n out, then we have a1 dot y over x. Please take note of that. When we remove x raised power n from x raised power n minus 1, we will be left with x raised power minus 1. And x raised power minus 1 from law of negative index, we turn to 1 over x. Okay, so the next one we have a2, then y squared over s squared. When we remove x raised power n from x raised power n minus 2, it will be left with x raised power minus 2. And x raised power minus 2 from law of negative index, we turn to 1 over x squared. All right, so we continue until we get to this a subscript n minus 1. Then we have y over x, y, okay, and we have these two. Then plus n minus 1 rather, minus 1. Then the last one we have a raised power n. We have y raised power n over x raised power n. Okay, so we have this. When x raised power n is removed from x, what will be left is x raised power n minus 1. Please let's take note of that, because by the time we multiply x raised power n with x raised power 1 over x raised power n minus 1, we definitely have this. Okay, so right now we have x raised power n into brackets a naught plus a1 y over x plus a2 y over x all squared plus a subscript n minus 1, then y over x, everything raised to power n minus 1, plus an y over x, everything raised to power n. All right, so we have successfully expressed this series in a form y over x. So everything is in terms of the y over x, and because of that, we shall be reforming that to be phi y over x. So we have successfully expressed f of x and y in the form x raised power n phi y over x. So taking note of the power of x here, we see that the order of homogeneity of the function is n. Okay, so that we mark the end of today's lecture. Thanks for watching, and please subscribe to our channel.